Welcome to Toad's IB Overview. Today we will be dividing polynomials. Let's start off with some vocabulary, which we will identify from this expression. This first polynomial is going to be our dividend. The dividend is the polynomial that is going to be divided. The second one is going to be our divisor, which is the polynomial we will be dividing by. From this, we will get an answer of 3x minus 5 with the remainder of 9x plus 10. Our answer is going to be called a quotient. And this is already the remainder. We can use long division to divide polynomials. We're going to put the polynomials in the format of the divisor on the outside and the dividend on the inside. Let's start off with an example. X squared plus 5x plus 6 divided by x plus 2. Put the x plus 2 on the outside and x squared plus 5x plus x plus 6, on the inside. From here, we have to look at the first term, x squared and x. X squared divided by x is going to give us x. Put the x here, as this has two terms and we're going to put it on the second term. From here, multiply x by x plus 2. Then put the answer here. So x times x is going to give us x squared, and then x plus 2, or x times 2, is going to give us 2x. We are then going to subtract these two terms with these two terms. X squared plus minus x squared is going to give us 0, while 5x minus 2x is going to give us positive 3x. Then we're going to bring down the positive 6. And we're going to repeat our steps again. Look at the first term, which is going to be 3x and x. 3x divided by x is going to be 3. Put the 3 here. So multiply the 3 by x plus 2, which is going to give us 3x plus 6. Then subtract these two together to get 0. We're going to have a remainder of 0. Our final answer is just going to be x plus 3. And we don't have to write the remainder because it is equal to 0. Let's try a second example. 6x to the power of 3 minus 16x to the power of 2 plus 17x minus 6, all divided by 3x minus 2. Put the 3x minus 2 on the outside. And the first polynomial on the inside. Let's look at the first term. 6x to the power of 3 divided by 3x. We're going to get 2x to the power of 2. Multiply the 2x to the power of 2 by 3x minus 2. We're going to get 6x to the power of 3 minus 4x to the power of 2. Then we're going to subtract to get our first term being 0, and then negative 12x to the power of 2. Now let's bring down the 17x and repeat the process. Negative 12x to the power of 2 divided by 3x is going to give us negative 4x. Multiply negative 4x by 3x minus 2. We're going to get 12x to the power of 2 plus 8x. Now subtract these two, which will get 0 here, positive 9x. Finally, bring down the last term, which is negative 6. 9x divided by 3x is going to give us positive 3. Here we're going to get 9x minus 6. Subtract, and our remainder is going to be 0. Our final answer is going to be 2x to the power of 2 minus 4x plus 3. Let's try another example. X to the power of 4 plus 3x to the power of 2 plus 1, all divided by x to the power of 2 minus 2x plus 3. First, let's put the second term on the outside. Then let's put the dividend in the inside. Here I'm going to put a 0 times x to the power of 3 because this polynomial here is going to be missing the x to the power of 3 as it goes from x to the power of 4 to x to the power of 2. This will be helpful later on when we're dividing. I'm also going to be putting a 0 times x, as it is also missing. Now let's divide. The first term, x to the power of 4, divided by x to the power of 2, is going to give x to the power of 2. Let's put this as the third term, since there are 3 terms in our divisor. Multiply x to the power of 2 by our divisor, and we're going to get x to the power of 4 minus 2x to the power of 3 plus 3x to the power of 2. Subtract, and we're going to get 0 plus 2x to the power of 3 plus 0x to the power of 2. And we're going to have to bring down this 0 times x. Now let's look at the first term again. 2x to the power of 3 divided by x to the power of 2. We're going to get 2x. Multiply 2x by the divisor, and we're going to get 2x to the power of 3 minus 4x to the power of 2 plus 6x. Subtract, and we're going to get 0 plus 4x to the power of 2 minus 5x. Finally, we're going to bring down the last term, which is 1. X 4x to the power of 2 divided by x to the power of 2 is going to give 4. Multiply 4 by the divisor, and we're going to get 4x to the power of 2 minus 8x plus 12. Subtract, and we're going to get 0, 3x minus 11. Here we can no longer divide further, so this is going to be our remainder. Our final answer is going to be x to the power of 2 plus 2x plus 4. And we're going to have a remainder of 3x minus 11. When there is a remainder, you can express it as a fraction over a divisor. So, for example, we have a remainder of 3x minus 11 in this question, and we can express it as a fraction over the divisor, which is x squared minus 2x plus 3. This will give us an exact value of the whole answer. So instead of a remainder of 3x minus 11, we can simply add this to the end of the equation. So this is going to be an exact value, depending on if your teacher wants you to express it as a remainder or not. Another method for dividing polynomials is synthetic division. Synthetic division can only be used when the divisor is a monomial in the linear form of x minus k. So this x has a coefficient of 1, an exponent of 1, and k is going to be the constant. Let's try this with an example. N to the power of 2 minus n minus 29 divided by n minus 6. First, we're going to write k. The value of k is going to be 6. Then we're going to put this sort of ladder and write the coefficients of our dividend. So the first coefficient is going to be 1. Our second one is going to be -1. And the last one is just a constant, so -29. You can put these commas here in order to better visualize it. Our next step is to bring this 1 down. We're going to write the 1 down here. Then we're going to multiply the 6 and the 1 to get 6. Here we're going to add -1 and 6, which we're going to get +5. Again, we're going to multiply 6 and then +5, which we're going to get 30. -29 plus 30 is going to give 1. 1 is going to be our remainder. So 1 and +5, these are going to be our coefficients of our answer. So we're going to have n plus 5. With a remainder of 1. Let's try another example. 42x to the power of 2 minus 33, all divided by 7x plus 7. Here we have to remember that 7x plus 7, which is going to be our divisor, needs to be in the form x minus k, where x has a coefficient of 1. So first, let's factor out the 7x, or the 7, from the 7x plus 7, which is going to be 7x plus 1. From here, we can just divide 42x to the power of 2 minus 33 by x plus 1. So k in this case is going to be -1. Put the -1 on the outside of the ladder, and we're going to have 42, the coefficient, 0, since this is missing an x, we're going to have 0x in its place, and -33. Let's bring down the first term, or the first coefficient. It's going to be 42. 42 times -1 is going to be -42. Then we're going to add 0 and -42. Multiply again. And then add again. 9 is going to be our remainder. We still have to divide the 7, so let's use long division for this. So 42 and -42 is going to be the coefficients of our answer. So we have 42x minus 42. 42x divided by 7 is just going to be 6x, which we're going to get 42x here. Subtract 0, bring the -42 down, which divided by 7 is just going to be positive. Not positive 6, it's going to be -6. Subtract, and we're going to get 0 as our remainder. Our final answer is then going to be 6x minus 6 with the remainder of 9, since we can't forget the 9 that we had originally. Let's try one last example for synthetic division. X to the power of 3 minus 4x to the power of 2 plus 3, all divided by x minus 1. First, k is going to be 1, which we'll write on the outside of the ladder, and then we're going to write the coefficients, which is going to be 1, -4, 0, since this is missing an x, and 3. Bring down the 1, multiply by 1 is going to give 1, and we're going to add to get -3, multiply again to get another -3, and then we're just going to add to another -3, and then our remainder is going to be 0. Final answer is going to be x to the power of 2 minus 3x and then minus 3. It's always going to be the coefficient is 1 less than that of the dividend. Our last method is factoring and canceling. Sometimes the answer is expressed as a fraction, so you have to use long division or synthetic division to obtain a quotient and remainder. This is after you've done factoring and canceling. Factoring and canceling is especially useful when both polynomials have the same degree. So let's try an example. (2x to the power of 2 minus x minus 15 divided by x to the power of 2 minus 2x minus 3. So first we can factor both polynomials, I'm going to use the product in sum method. So product here is going to have to be -30, the sum of -1. I'm just going to move everything down. The two numbers we're going to use is -6 and 5. I'll put the coefficient of the leading term here in the numerator, so 2. Just going to give 1 over -3, and that's just going to be 2 over 5. So we have x minus 3 times 2x plus 5. For a second one, we have a product of -3, sum of -2. The two numbers we're going to use is -3 and +1. So we have x minus 3, x plus 1. Let's put this in a fraction form to better visualize it. Our dividend is going to be in the numerator and the divisor is going to be in the denominator. So here we can cancel out the x minus 3. We're going to get 2x plus 5 over x plus 1. Your teacher may require you to write a restriction, which is going to be x. We cannot be equal to 3. If you need to simplify this further, use synthetic division or long division. Let's try one last example. X to the power of 3 plus 3x to the power of 2 minus 6x minus 18, all divided by x to the power of 3 plus 7x to the power of 2 plus 12x. Let's factor the first polynomial first. So we can factor out x to the power of 2 from the first two terms. So we have x to the power of 2 times x to the power of 3. We can also factor out -6 from the last two terms. This is factoring by grouping. Now let's factor the divisor. So we have x to the power of 3 plus 7x to the power of 2 plus 12x. All of them have an x in common. So let's factor x out. And then use product or sum method or any other method to factor out this polynomial. So we need a product of 12 and a sum of 7, which is going to be 3 and 4. So this is going to become x plus 4 times x plus 3. Oh, and I almost forgot. We can express this as x to the power of 2 minus 6 and x plus 3. Now we can express this as a fraction. So the dividend on the top and the divisor on the bottom. So we're going to cross x plus 3 out. Final answer is going to be x to the power of 2 minus 6 x times x plus 4. Your teacher may want you to expand the denominator, which is going to be x to the power of 2 plus 4x. And don't forget the restriction as well if you need to put that. So that will be it for factoring or just dividing polynomials in general. If you want to see more math lessons, please check out our other videos.